What if we told you that Earth's oceans might not be unique? From the icy moons of Jupiter to the distant exoplanets, you'll be amazed by what might exist on other planets. These questions have ignited our imaginations for centuries, and now, believe it or not, we're on the brink of perhaps finding the answers. The relentless quest to explore space has led to the discovery of, get this, over 4,000 exoplanets. All thanks to NASA's unwavering dedication and the invaluable Kepler Space Telescope. Each discovery is like a powerful thrust, taking us ever closer to the exhilarating prospect that we may not be alone. So now, when we think about the possibility of oceans on other planets, we have to delve into the idea of the habitable zone. It's this magical region around a star where everything's just perfect. Not scorching hot, not freezing cold, for liquid water to exist on a planet's surface. And remember, where there's water, there lurks the possibility of life. But you might wonder, how common are these Goldilocks zones? Well, NASA tells us that a staggering 20 to 50% of stars observed have planets in this habitable zone. Now that's a mind-blowing fact. Imagine the hundreds of billions of stars in our galaxy alone, and now, brace yourself, up to half of them might be hosting a planet with conditions perfect for life as we know it. Now, let's not jump the gun. Just having a planet in the habitable zone doesn't automatically mean an ocean is present. Of course, there are countless other aspects to consider, like the planet's atmosphere and geological activity, among many others, but it does signify that these planets hold the potential for liquid water. And where there's water, there's hope for life. So here we are, standing on the edge of an unprecedented frontier, the thrilling possibility of discovering an alien ocean, potentially swarming with life, or at the very least the chemical precursors to life, is absolutely tantalizing. Ready for a cosmic adventure? We're jetting off a staggering 110 light-years away to the exotic exoplanet K2-18b. Here's a fun fact for you. Back in 2019, scientists using the Hubble Space Telescope hit the scientific jackpot. They detected water vapor in the atmosphere of this distant planet. Now you might be thinking, so what? But here's the fascinating part. Out of the over 4,000 exoplanets we've discovered so far, K2-18b is our solitary champion, where we've detected water vapor. This discovery is like unearthing a single precious diamond in the vastness of the Sahara Desert, a tantalizing hint of the potential for life, as we understand it. The presence of water vapor doesn't automatically mean oceans, but oh boy, a thrilling clue that such bodies of water could be out there on other worlds. Now we're eyeing up our cosmic neighbor, Mars. Mars has long been the epicenter of our quest for extraterrestrial life, and let me tell you why. In 2008, the Phoenix Mars lander unearthed water ice just beneath the Martian surface. This was later echoed by the Mars Reconnaissance Orbiter, which discovered evidence of vast ice deposits. To give you an idea of the scale, these deposits cover an area larger than the European Union. Imagine this, if all this ice were to melt, it could drench the whole Martian surface with a layer of water 35 meters deep. Incredible, right? So why does this matter? Well, it may not be definitive proof of oceans on other planets, but it's a compelling hint that the ingredients for such bodies of water are out there, waiting to be discovered. These discoveries ignite our imagination about the potential for extraterrestrial oceans. And they stoke the flames of our quest to answer one of the most profound questions in science. Are we the only life forms in this vast universe? But, oh boy, the universe is one thrilling place. How do distance, temperature, and pressure shape the existence of oceans? Let's dive right into it, starting with distance. Picture the sheer, mind-boggling expanse of space. The closest star to us, Proxima Centauri, is an awe-inspiring 4.24 light-years away. That's a jaw-dropping 25 trillion miles. Yes, you heard that right, trillion with a T. It's a distance so colossal, so unimaginable, it's like flying to the moon and back over a whopping 1,300,000 times. This enormous distance forms a thrilling challenge in our great voyage to discover oceans on other planets. Now let's switch gears to temperature. The existence of liquid water, the star of our earthly oceans, is totally tied to temperature. At just the right temperature, water thrives in a liquid state, giving birth to oceans. Too hot and water takes a hike, evaporating into thin air. Too cold and it freezes. Somewhere between these extremes is the Goldilocks zone, a perfect range of temperatures where liquid water can happily exist. But finding a planet in this zone is like hunting for a needle in a cosmic haystack. How exciting is that? We cannot forget about pressure. The pressure needs to be in that sweet spot for water to exist as a liquid. Here we stumble upon the concept of the triple point. It's this unique set of conditions where water can show off all its forms, solid, liquid, and gas all at once. On Earth, we're comfortably above water's triple point, living the liquid water dream. But on Mars, for example, the lower atmospheric pressure means water jumps straight from ice to vapor. The interplay of distance, temperature, and pressure in the universe makes the existence of oceans a rip-roaringly complex puzzle. It's like trying to hit a bullseye from miles away in a windstorm while teetering on a tightrope. But heck, it's a puzzle we're totally stoked to solve. These challenges just add more spice to our quest for extraterrestrial oceans. Imagine what we could achieve with the James Webb Space Telescope. This could completely transform our quest for extraterrestrial oceans. Now imagine a telescope with such magnificent power that it can penetrate into the atmospheres of far-off planets, capturing the faintest whispers of water vapor. This isn't the premise of a sci-fi novel, but an actual reality. The incredible James Webb Space Telescope, and this awe-inspiring piece of technology, is set to propel our cosmic knowledge to unimaginable heights. Its extraordinary sensitivity will grant us the ability to spot water vapor in the skies of exoplanets, those mysterious, intriguing planets orbiting stars beyond our own solar system. But why all this fuss about water vapor, you ask? The answer is straightforward. Water is the lifeblood of life as we know it. Discovering water vapor in an exoplanet's atmosphere may mean the presence of surface water, and where there's water, who knows, there could potentially be life. Let's take a moment to marvel at the mind-boggling scale of our galaxy. In a universe where 20 to 50% of stars may host planets in the habitable zone, the Goldilocks zone, where conditions could be just right for liquid water, the possibilities are staggering. With billions of stars in our galaxy alone, the odds are electrifying. The James Webb Space Telescope could potentially unveil an abundance of planets with the right conditions for water and possibly even life. Remember, the journey is every bit as worthwhile as the destination. The data and insights gleaned from the James Webb Space Telescope will enrich our understanding of the universe, igniting our curiosity and fueling our passion for exploration. The hunt for extraterrestrial oceans is an exhilarating venture, a voyage into the uncharted that could redefine our position in the cosmos. With the James Webb Space Telescope, the tools for this exciting exploration are right at our fingertips. The James Webb Space Telescope makes the prospect of discovering extraterrestrial oceans beyond exhilarating. So, could there be oceans on other planets? This thrilling question has had us on the edge of our seats. Let's take a quick jaunt down memory lane and revisit what we've learned. We've journeyed through the cosmos and scrutinized the evidence of up to 4,000 exoplanets in our very own galaxy. Everyone a unique world brimming with potential for water. We've dived deep into the significance of one single detection of water vapor on an exoplanet, a mind-boggling 110 light-years away, which ignited a beacon of hope for an exciting new understanding of our vast universe. The universe, a playground of boundless possibilities, and the race to find extraterrestrial oceans is still on. With every groundbreaking discovery, we inch tantalizingly closer to unraveling this riveting mystery.